Welcome students. Let's have a quick recap of what we have studied in the last session. A computer is an electronic device that can be programmed to accept data and instructions as input. It processes the data according to instructions provided and produces output. Data is raw facts and figures, and information is processed data. A computer system has 4 components: hardware, software, firmware and liveware. Further, hardware can be divided into 4 major parts: input unit, central processing unit, memory unit and output unit. A computer follows input, process, output cycle to perform a task. Measuring units for digital data. Students, today we will learn about software and its needs, types of software, operating system user interface, functions of the operating system. Till now, we have studied about the physical components of the computer system. We cannot instruct the hardware of a computer directly. Hardware needs to be operated by a set of instructions. These set of instructions are referred to as software. So, we can define software as a set of instructions and data that makes hardware functional to complete the desired task. It is that component of a computer system which we cannot touch or view physically. Software acts as an interface between human users and the hardware. Some examples of software include operating system like Ubuntu or Windows, word processing tool like LibreOffice or Microsoft Word, video player like VLC player, photo editors like GIMP. Our next topic is types of software. Depending on the mode of interaction with hardware and functions to be performed, the software can be broadly classified into 3 categories. First, system software, second, programming tools, and third one is application software. Let's understand each one of them in detail. First one is system software, the software that provides the basic functionality to operate a computer by interacting directly with its constituent hardware is known as system software. A system software knows how to operate and use different hardware components of a computer. A system software can be classified as operating system, system utilities, device drivers. Let us understand each one of them. First one is operating system. As the name implies, the operating system is a system software that operates the computer. An operating system is the most basic system software without which other software cannot work. The operating system manages other application programs and provides access and security to the users of the system. Some of the popular operating systems are Windows, Linux, Macintosh, Fedora, Android. The second one is system utilities. Software used for maintenance and configuration of the computer system is called system utility. Some system utilities are delivered with the operating system, for example, disk defragmentation tool, formatting utility, system restore utility. There are some system utilities that are not delivered with the operating system, but are required to improve the performance of the system. For example, antivirus software, disk cleaner tool and disk compression software. Third one is device drivers. As the name suggests, the purpose of a device driver is to ensure proper functioning of a particular device. When it comes to the overall working of a computer system, the operating system does the work, but every day new devices and components are being added to a computer system. It is not possible for the operating system alone to operate all of the existing and new devices, where each device has diverse characteristics. The responsibility for overall control, operation and management of a particular device at the hardware level is delegated to its device driver. A device driver acts as a mediator between the operating system and the attached device. It provides required services by hiding the details of operations performed at the hardware level of the device. Our next topic is program development tools. In order to get some work done by the computer, we need to give instructions which are applied on the input data to get the desired outcome. Computer languages are developed for writing these instructions. In order to simplify the program development, there is software called Integrated Development Environment consisting of text editor, building tools and debugger. A program can be typed, compiled and debugged from the IDE directly. Examples of some IDEs are Python IDE, NetBeans, Eclipse, Atom, Lazarus. Whenever we write a program, we need a text editor. A text editor is a software that allows us to create a text file where we type instructions and store the file as the source code. Then, an appropriate translator is used to get code in machine language known as the object code for execution of the program, and debugger is the software used to detect and correct errors in the source code. Before starting with the language translators, let's understand what are low-level and high-level programming languages. In order to get some work done by the computer, we need to give instructions which are applied on the input data to get the desired outcome. Computer languages are developed for writing these instructions. Two major categories of computer programming languages are low-level languages and high-level languages. Low-level languages are machine-dependent languages and include machine language and assembly language. Machine language uses ones and zeros to write instructions which are directly understood and executed by the computer. But writing a code in machine language is difficult, as one has to remember all the operation codes and machine addresses. Also, finding errors in the code written in machine language is difficult. To simplify the writing of code, assembly language was developed that allowed usage of English-like words and symbols instead of 1 and 0. But one major drawback of writing a code in assembly language is that the code is computer specific, which means the code written for one type of CPU cannot be used for another type of CPU. Later on, high-level languages were developed that are simpler to write code and machine independent. High-level language programs are written using a set of rules similar to natural languages like English. Examples of high-level language include C++, Java, Python. Now, we know that computer and humans understand completely different languages. While humans are able to write programs in high-level language, computers understand low-level language. There is a need for conversion from high-level to low-level language, for which translators are needed. As I told you earlier, the computer can understand only machine language. A translator is needed to convert a program written in assembly or high-level language to machine-level language. The program code written in assembly language or high-level language is called source code. The source code is converted by language translator into machine understandable form called machine or object code. There are three types of translators: assembler, compiler and interpreter. The translator used to convert the code written in assembly language to machine language is called assembler. Each assembler can understand a specific microprocessor instruction set only, and hence the machine code is not portable. The translator used to convert the code written in high-level language to machine understandable form is known as compiler. If the code follows all syntactical rules of the language, then it is executed by the computer. Once translated, the compiler is not needed. Compiler translates and executes the entire program in one go. An interpreter translates one line at a time instead of the whole program in one go. Interpreter takes one line, converts it into executable code if the line is syntactically correct, and then it repeats these steps for all lines in the source code. Hence, interpreter is always needed whenever source code is to be executed. Our next topic is application software. The system software provides the core functionality of the computer system. However, different users need the computer system for different purposes depending upon their requirements. Hence, a new category of software is needed to cater to different requirements of the end user. This specific software that works on the top of the system software is termed as application software. Application software refers to the computer programs or software applications designed to perform specific tasks or provide specific functionalities to end users. There are two broad categories of application software: general purpose software and customized application software. First one is general purpose software. The application software developed for generic applications to cater to the needs of the common users are called general purpose software. Such ready-made application software can be used by end users as per their requirements. For example, MS Office, Adobe Photoshop, Mozilla web browser. It is similar to buying ready-made garment with the fitting, color and fabric of our choice. Next is customized software. These are custom or tailor-made application software that are developed to meet the requirements of a specific organization or an individual. They are better suited to the needs of an individual or an organization, considering that they are designed as per special requirement. Example, school management software, accounting software. It is similar to buying a piece of cloth and getting a tailor-made garment with the fitting, color and fabric of our choice. Let's understand what are proprietary or free and open source software. A software can be freeware or open source or proprietary software, depending upon the terms and conditions of the person or group who has developed and released the software. The developers of some application software provide their source code as well as the software freely to the public with an aim to develop and improve further with each other's help. Such software is known as free and open source software. For example, Ubuntu, Python, LibreOffice, OpenOffice, Mozilla Firefox. Sometimes software is freely available for use, but the source code may not be available. Such software is called freeware. Examples of freeware are Skype, Adobe Reader. When the software to be used has to be purchased from the vendor who has the copyright of the software, then it is a proprietary software. Examples of proprietary software include Microsoft Windows, Tally, QuickHeal. Students, our next topic is operating system. A computer system can work without application software, but it cannot work without system software. For example, we can use a computer even if no word processing software is installed, but if no operating system is installed, we cannot work on the computer. So, operating system is the most important system software. An operating system can be considered to be a resource manager which manages all the resources of a computer. It also controls various application software and device drivers, manages system security and handles access by different users. Examples of popular operating system are Windows, Linux, Android, Macintosh. There are two primary objectives of an operating system. The first one is to provide services for building and running application programs. When an application program needs to be run, It is the operating system which loads the program into memory and allocates the CPU for execution. When multiple application program needs to be run, the operating system decides the order of execution. The second objective of the operating system is to provide an interface between the user through which the user can interact with the computer. A user interface is a software component which is a part of the operating system and whose job is to take commands or inputs from a user for the operating system to process. Now, we will explore different types of operating system user interface. First one is command based interface. Command based interface requires a user to enter the commands to perform a task like creating, opening, editing or deleting a file. The user has to remember the names of all such programs or specific commands which the operating system supports. The input device used for command based interface is the keyboard. Command based interface is often less interactive and usually allows a user to run a single program at a time. Examples of operating system with command based interface include MS-DOS and Unix. The second one is graphical user interface. Graphical user interface lets users run programs or give instructions to the computer in the form of icons, menus and other visual options. Icons usually represent files and programs stored on the computer, and windows represents running programs that the user has launched through the operating system. The input devices used to interact with the GUI commonly include the mouse and the keyboard. Examples of operating system with GUI interface include Microsoft Windows, Ubuntu, Fedora and Macintosh. The third one is touch based interface. Today, smartphones, tablets, PCs allow users to interact with the system simply using the touch input. Using the touch screen, a user provides inputs to the operating system which are interpreted by the operating system as command like opening an app, closing an app, dialing a number, scrolling across apps. Example of popular operating system with touch based interface are Android and iOS. Here iOS is iPhone operating system. The fourth one is voice based interface. Modern computers have been designed to address the needs of all types of users, including people with special needs and people who want to interact with computers or smartphones while doing some other task. For users who cannot use the input devices like the mouse, keyboard and touch screens, modern operating systems provide other means of human computer interaction. Users today can use voice based commands to make a computer work in the desired way. Some operating systems which provide voice based control to users include iOS, Android, Microsoft Windows 10, Cortana. Fifth one is gesture based interface. Some smartphones based on Android and iOS as well as laptops let the users interact with the devices using gestures like waving, tilting, eye motion or shaking. This technology is evolving faster and it has promising potential for application in gaming, medicine and other areas. Now, let us explore the important services and tasks that an operating system provides for managing the computer system. First one is process management. While a computer system is operational, different tasks are running simultaneously. A program is intended to carry out various tasks. A task in execution is known as process. We can activate a system monitor program that provides information about the processes being executed on a computer. In some systems, it can be activated by using Ctrl Alt Delete keys together on the keyboard. It is the responsibility of the operating system to manage these processes and get multiple tasks completed in minimum time. As CPU is the main resource of computer system, its allocation among processes is the most important service of the operating system. Hence, process management concerns the management of multiple processes, allocation of required resources and exchange of information among processes. Second is memory management. Primary or main memory of a computer system is usually limited. The main task of memory management is to allocate and take free memory from running processes. Since there are multiple processes running at a time, there arises a need to dynamically allocate and free memory to the processes. Operating system should do it without affecting other processes that are already residing in the memory. And once the process is finished, it is again responsibility of the operating system to take the memory space back for reutilization. Hence, memory management concerns with management of main memory, so that maximum memory is occupied or utilized by a large number of processes while keeping track of each and every location within the memory as free or occupied. The third one is file management. Data and programs are stored as files in the secondary storage of a computer system. File management involves the creation, updation, deletion and protection of these files in the secondary memory. Protection is a crucial function of an operating system, as multiple users can access and use a computer system. There must be a mechanism in place that will stop users from accessing files that belong to some other user and have not been shared with them. File management system manages secondary memory, while memory management system handles main memory of a computer system. Fourth one is device management. A computer system has many input-output devices and hardware connected to it. Operating system manages these heterogeneous devices that are interdependent. The operating system interacts with the device driver and the related software for a particular device. The operating system must also provide the options for configuring a particular device, so that it may be used by an end user and some other device. Just like files, devices also need security measures, and their access to different devices must be restricted by the operating system to the authorized users, softwares and other hardware only. Let us summarize what we have studied today. Software is a set of instructions written to achieve the desired task and are mainly categorized as system software, programming tools and application software. System software include operating system, system utilities, device drivers. The language translators are used to convert the code written in assembly or high level language to machine language. There are three types of translators: assembler, compiler and interpreter. Application software refers to the computer programs or software applications designed to perform specific tasks or provide specific functionalities. There are two categories of application software: general purpose and customized application software. Operating system is an interface between the user and the computer and supervises the working of computer system. System utilities are software used for maintenance and configuration of the computer system. Device drivers are responsible for control, operation and management of a particular device. Different types of operating system user interface are command based interface, graphical user interface, touch based interface, voice based interface and gesture based interface. Functions of operating system are process management, memory management and file management and device management. Students, Note down the homework assignment based on today's session. Question 1. Explain the need of language translator. Question number 2. Give example of 3 system utilities. Question 3. Why do we need a device driver? Question 4. Define debugger. Question number 5. How a compiler is different from an interpreter. Question number 6. Write a short note on functions of operating system. Question number 7. List different types of operating system user interface. Question 8. How command based interface is different from graphical user interface. Dear students, with this we have completed chapter 1. I hope you found today's session enjoyable and enriching. Wishing you a wonderful day ahead filled with positivity and continued success. Goodbye.